So in the previous video, we have covered the solution of homogeneous state equation, right, using the Laplace transform, and also we have covered the state transition matrix, their properties, and I think we have covered some numerical portion, right. Today, sorry, we are going to cover the topic that is the solution of non-homogeneous state equation. So please tell me what do you understand by the homogeneous and non-homogeneous state equation? Yes, please. For the non-homogeneous equation, what do you understand?
Sir, U of t on a matrix 0 nu.
Yes, very good. Homogeneous equation ut is not equal to the 0, right? And also you can say that there are two conditions for the solution of non-homogeneous, because since it is not 0. Okay, so it may be, we can consider the when the first condition is when initial time, okay, when initial time is given by t is equals to 0. The initial condition should be the maybe the 0, or the second condition it may be the when initial time is given by t is equals to, let's say, t naught. So in both the cases, what will be the solution of the equation, we will try to learn. Okay, so the first condition we are considering first. Pehla condition, case 1. Case 1, you can say the case 1 is, let's say, when initial time is given by t equal to 0, right? So what is the state equation? Our state equation, that is a non-homogeneous state equation, obviously, is given by, anyone can tell me what will be the state equation? Yes, please. X dot
T is equals to ax plus bu.
axt plus bu. Very good. Axt plus bu. Very good. This is the equation. Okay. Now, considering the analogous or the scalar function, right? Considering here A is the matrix, B is the matrix, B is the vector, right? A is the vector. So हमने क्या किया, इसका एक analogous scalar vector, scalar function we can consider, and that scalar equation can be given by the a of xt plus small b ut, right? So this is equation number 2. Okay, you can say that where a and b are the scalar function, right? Scalar function. Now take the Laplace transform. How the solution will take? हमने कैसे लिया था? हमने इसका Laplace transform लिया था. Taking the Laplace transform of equation number 2, right? क्या बन जाएगा जरा बताइए? Please tell me. S of xs minus x0 is equals to ax of s plus anyone b us. Am I right? Yes or no?
Yes, sir.
So s minus a into of xs equal to x of 0 plus bus. ठीक है ना? bus. You can write here also the x of s equal to s minus a inverse x0 plus s minus a inverse bus. This is equation number 3. Right? ठीक है? Yes or no? Okay. Taking the Laplace inverse. Taking the Laplace inverse of the equation number 3. क्या बन जाएगा? Please tell me. This becomes xt. यही तो हमको चाहिए, सॉल्यूशन तो चाहिए. और what is this? What is this? ये है क्या?
e to the power 80.
E to the power 80. E to the power 80 x0. This is what is x0? X0 is the initial condition. Okay. Plus what is this? ये है क्या? ये क्या है? ये आपका convolution. What is this? This is a convolution. We have already studied in the signal system. So we can write here, it is the 0 to t, right? E to the power a t minus tau b u tau d tau. So this is the convolution. Okay, so we can represent the equation like this. Okay, now the final equation, you can say the xt becomes hence for the equation 1, that is the vector form. The vector form of the equation, ये तो एनालॉगस के लिए स्केलर फंक्शन के लिए था. Now you can generalize it for the equation number 1, that is the e to the power a t x of 0 plus 0 to t e to the power a t minus tau b u tau d tau. Okay, this is equation number 5. Or also it can be written as, or this equation may be written as xt is equals to e to the power at is, you know, this is the phi t, right? Phi t plus 0 to t phi t minus tau b u tau d tau. So this is the equation. So this is the solution. Okay, these are the solution. You can say this is the solution of the non-homogeneous state equation where the initial condition t equal to 0. Right? Understood? Now the problem becomes little bit complex when your initial condition, now initial time, case 2, when initial time is given by t is equals to t naught, right? Okay, as you have seen this equation number 6, you can write from equation number 6, you know, the xt is equals to phi t x naught plus 0 to t phi t minus tau, okay, b u tau d tau, right? So ये तो आपका t is equals to, at t is equals to t naught, t is equals to t naught अगर हो गया तो this equation is modified, x of t naught is equals to phi t naught x 0 plus 0 to t naught phi t naught minus tau b u tau d tau. This equation will become like this. Okay, now what you will do, you just multiply the equation, this equation number, let's say 7. So now multiply the equation number 7, right, both side by phi inverse t naught. हमने क्या किया, phi inverse t naught से दोनों साइड multiply किया. Then the equation becomes, please tell me what will the equation become? Main important thing is derivation, right? और इसको हम लोग derivation, हम लोग को xt चाहिए और xt के लिए at t equals to t naught, at t is equals to t naught, we are trying to find out the value of xt, right? So in order to that, what we are doing, see, so phi inverse हमने t naught से multiply किया both side, so then equation becomes phi inverse t naught x into t naught is equals to phi inverse t naught into phi t naught becomes identity matrix, that is I, and it becomes x0 plus 0 to t naught phi of minus t naught, because you know the property, this is the property minus phi of t naught, right? And this is the phi t naught minus tau bu tau d tau, right? ठीक है, ये प्रॉपर्टी आप जानते हैं, चूंकि सिंस द phi inverse t naught is equals to nothing but you can write the minus of phi t naught. So based on this property just we have used, right? So the equation becomes x0 plus 0 to t naught phi, yes please tell me, minus of t naught plus of t naught minus tau bu tau d tau. Can I write? Yes or no? Yes or no? बोलता नहीं है सब. Are yes or no?
Yes, sir.
So the equation now becomes x0 plus 0 to t naught phi of minus tau, because this will cancel, phi of minus tau bu tau d tau. Okay. So
Yes, sir.
now this is your phi inverse. Remember, phi inverse t naught into x of t naught है ये. Remember. Okay. So putting phi inverse t naught, right, equal to phi minus of t naught, then x naught become x0 become. अब ये क्या बनेगा देखिए, यहां पर मैंने इसको, यहां पर भी मैंने इसको लिख दिया phi ऑफ माइनस टी नॉट इंटू ऑफ एक्स टी नॉट इज इक्वल टू ये पूरा, और x0 अब क्या बन गया बेटा, x0 बन गया. नाउ योर x0 विल becomes phi of minus t naught into x of t naught minus 0 to t naught phi of minus tau bu tau d tau. This is the x0. Yes or no? Any doubt? This is the equation number 8. Hence xt now become, यहां से आप x0 निकाल लिया, ठीक है ना, कोई प्रॉब्लम तो नहीं है. Now xt, what is xt now? xt is your xt now become, क्योंकि आपको x नॉट की वैल्यू पता है. नाउ यू नो द x नॉट एंड यू नो दैट द वैल्यू ऑफ xt वाज, आपने पहले भी लिखा है, देखिए you have already written xt is equals to this value, xt is equals to this is the answer, and now you know the value of x naught, you know the value of x naught, just put the value and whatever that value will become, that will your result, right? You know that your phi t xt is nothing but the phi t, okay, into x of x naught plus 0 to t phi t minus tau bu tau. यही था ना आंसर, राइट? सो मैंने खा लिया, ये हिमांशु का है ना?
नहीं, एक तो खाना पड़ेगा, नरेंद्र सिंह सर बोलते हैं कि टेस्टी है.
अच्छा,
है ना? चलो ठीक है सर, थैंक यू.
तो xt become phi t, and what is the x naught? X naught is this value. So just put this value x naught phi of minus t naught x of t naught minus 0 to t naught phi of minus tau bu tau d tau. plus 0 to t phi t minus tau b u tau d tau. So this is equation number 9. समझ में आ गया बात? Yes or no? Yes or
Yes,
no?
sir.
So finally you can write xt is equals to phi. जब इसको सॉल्व करेंगे, जब अंदर ले जाएंगे तो, क्योंकि you know phi t into phi t1 into phi t2 आपने पढ़ा है, phi t1 plus t2. Yes or no? This is a property. So you can write here t minus t naught x of t naught minus, और this is the, now इसको और इसको कंबाइन कर दिया जाए, then your equation becomes, right, t naught to t, है ना, because this is a 0 to t और 0 to t naught है, ठीक है, तो हमने इसको ब्रेक कर दिया t से 0 से t and t से t naught, right, then we have taken t naught to t. So ultimately the equation becomes phi t minus tau b u tau d tau, right. So this is the final answer, right. Or this equation may be represented like in the term of the e to the power at, xt is equals to e to the power a t minus t naught x of t naught plus 0 to t e to the power a t minus tau b u tau d tau. So this is equation number 10, this is equation number 11. So these are the solution of, you know, the non-homogeneous linear equation, non-homogeneous state equation, where the initial time is given by t naught, right. Any question, any query? If not, then we will proceed to the numerical problem. Okay, so previously I have given one numerical problem to you for the solution. Question was a LTI system. LTI system is characterized by homogeneous state equation x dot t equal to 0 1 minus 6 minus 5 xt, right. The initial condition, the initial state is given, that is the x naught is equals to 1 0. So question is determine the resolvent matrix phi s and STM phi t and solution. So roll number 22. Roll number 22.
Yes, sir.
Please tell me how we can proceed. The initial value is given, the state equation is given. First of all, tell me what is the solution of this equation. This is the first of all identify this is the homogeneous or non-homogeneous equation. Homogeneous equation. ठीक है. So this is the homogeneous equation. So what is the solution for the homogeneous equation? What is the solution for the homogeneous equation xt? I already told you phi t into x naught. Phi t into x naught, right? What is the phi t? What is phi t? What is phi t? Phi t is the STM.
Laplace inverse of S.
Yes, that is the Laplace inverse of phi s, right?
Yes.
This is a Laplace inverse of Si minus of A inverse, right? Si minus A inverse. Okay. So what is the Si? What is the A? What is the A matrix? A matrix is given 0 1 6 minus 6 minus 5, right? So Si minus A, you can write S0 0 S minus of A, 0 1 minus 6 minus 5, and this is become the Si minus A, S minus 1 6 and then S plus 5. Right, now we have to calculate the Si minus A inverse. So adjoint of a determinant of a, yes. तो इसको इधर करते हैं, इसको इधर करते हैं, यस और नो, मालूम है ना, और इनका साइन चेंज कर देते हैं, ठीक है, और उसके बाद नीचे में डिटरमिनेंट लेते हैं, राइट. सो इट विल बिकम S plus 5 upon S plus 5
S plus
upon
2 S plus 3.
Yes, S plus 2 and S plus 3. Very good. And then the here it becomes
So 1 upon S plus 2 S plus 3.
S plus 2 S plus 3, and here it becomes minus 6 upon S plus 2 S plus 3, and here it becomes S, है ना, इसको यहाँ S आ जाएगा, and then the S plus 2 S plus 3, right. यहाँ का हम लोग साइन चेंज करते हैं बेटा, यहाँ का है ना, और इसको हम लोग आपस में एक्सचेंज करते हैं, राइट, और नीचे में डिटरमिनेंट. सो नाउ यू, दिस इज the Si minus A inverse. So finally you can calculate the Laplace inverse of this function, and using the partial fraction, you can calculate the resolvent matrix, that is phi t, and phi t is nothing but, you know, Laplace inverse of phi s, or you can say the Laplace inverse of Si minus A inverse, right. So it will come, when you solve with the help of the partial fraction, it will come 3 e to the power minus 2t minus of 2 e to the power minus 3t, e to the power minus 2t minus e to the power minus 3t, 6 e to the power minus 3t minus e to the power minus 2t, and then 3 e to the power minus 3t minus 2 to the power minus 2t. So this is the solution. This is the phi t, right. So the solution of a state equation, right, that is the xt, is given by phi t into x0. Okay, and phi t already you know, x0 is already given, x0 is given as 1 0. Just you can multiply both the equation and you can find out the xt. Then when you multiply both the equation, then it will come like 3 e to the power minus 2t minus 2 e to the power minus 3t, and
First column.
first column है, क्योंकि second तो 0 है, and 6 e to the power minus 3t minus e to the power minus 2t. So this will be the answer of xt, right. Second question and last question of today, this video, example number 2. Find the time response of the system described by the equation. Equation was given x1 dot, x2 dot, 0 1 minus 6 minus 5, x1 x2 plus 0 1 u, and the initial condition x1 0 and x2 0 is given in the term of 1 0, and also the ut is given as 1 for t greater than 0. This is the condition. So already you know the solution of this. It is a homogeneous or non-homogeneous?
Non-homogeneous.
So for the non-homogeneous equation and for the initial value is given, right. So you can find out the solution. You can write out the solution of a state equation is given by xt is equals to phi s x0 plus 0 to t phi t minus tau bu tau d tau, right. ये आपका इक्वेशन था. Yes or no? बोलो ठीक है. This was the solution. Right? और you have already written phi t minus e to the power minus t minus t, no? ठीक है ना? इसके बेसिस पर just calculate all this thing. Okay. So we will discuss tomorrow. We will solve this numerical tomorrow. Till my suggestion is to revise the solution of the non-homogeneous and homogeneous equation and try to practice the numerical based on this, right?
Sir.
Yes.